In this video, we shall discuss the Gauss Divergence Theorem. A short statement of this theorem is the following. Let us try to understand this. V is a region of the three-dimensional space whose boundary is S. So just one remark here to begin with. V is not the volume in the sense that it is the volume of a solid and it will be a number. So when I say volume in today's context, it is going to be a collection of points in a region of space, three-dimensional space. So this, for example, so S is the surface and V is the collection of all points enclosed by this surface. So the left hand side is a statement about all the points within S, within and on S, and the right hand side is a statement only about the surface. So on the left hand side we have a triple integral, a volume integral, and on the right hand side we have a surface integral. Del dot F bar is called as the divergence of the vector field F bar. So what is the left hand side actually doing? Divergence, as we know, is the measure of the strength of the source. So if one is looking at del dot F bar at each point of V, then one is looking at how much is being generated, how much of, let us say, mass is being generated at that particular point. So when you're looking at the left hand side, you're looking at how much mass is being generated at each point of V, and that will be the total mass generated at V. Now this mass could be positive or negative. So the left hand side is actually looking at the sum total, the net mass generated by all points of V. So suppose the mass which is generated by V, you can think of this as fluid flow, and each point being a source or a sink which generates some fluid or it absorbs some fluid. So if this fluid is going outside V, it has to cross S. And therefore let us focus our attention at a particular point of S. And let us look at a small patch around that particular point. So what is F bar? F bar is the flow. Let's take it like that. F bar is the flow at that particular point. One can look at the components of the flow, one perpendicular, normal to the surface element, and one is tangential to it. Now the component which is responsible for bringing the mass out of the surface is the one which is perpendicular to the surface element, right? And when you're looking at f bar dot ds bar, you're actually looking at the sum total of the mass which is flowing out of this surface element. And what you're doing on the right hand side is adding up all such flows which are normal to the surface, and therefore the right hand side measures the sum total of the flow through S, through the surface S. And what is the left hand side measuring? It is measuring the mass generated by each point. All right, and obviously these two things must be same if we believe in the conservation of mass. So this statement is the statement of conservation of mass. So that is what is Gauss divergence theorem. Another way of looking at this theorem is that it is a transformation of a surface integral into a volume integral and vice versa. So just for the sake of records, let me just write down the interpretation which I gave. So what is the left hand side? The left hand side is sum total of the mass generated by V. And what is the right hand side? It is the sum total of mass flowing through S. Okay, so this is the interpretation of Gauss divergence theorem. Now this theorem, I mean, when is this theorem going to hold? Obviously it is not going to hold for any F and any S and any V. All right, but normally in engineering applications V and S are not very complicated, and when we solve problems, the usual S would be, you know, a sphere or a section of a sphere, solid sphere, or it could be, say, a paraboloid, a finite a section of a finite section of a paraboloid, section of para V, and then V and S, so they go side by side. A finite section of a paraboloid or a finite section of a cone or a finite section of a cylinder, and maybe a finite number of these objects. All right, so these will be all nice situations, and one can apply Gauss divergence theorem. Fine, so that's all in this video. In the next video, I will take up some examples to illustrate the Gauss divergence theorem and Stokes theorem.